All right, good morning, folks. Today we continue with our diluting solutions. It's going to be more interactive, so get your calculator, your pencil, your writing material, and your scratch paper to go along with us. All right, thank you.
MI times VI equals MF times VF. MI equals 18.0. VI equals, to be calculated, MF equals 0.22. VF equals 0.10. Therefore, VI equals 0.22 times 0.10 divided by 18.0 equals 0.0012. However, VI is expressed in liters, and we need our answer in milliliters. Thus, 0.0012 liters times 1,000 milliliters divided by 1 liter equals 1.2 milliliters. Example: how many liters of 0.50 molar acetic acid solution can be formed from 0.30 liters of 2.0 molar acetic acid solution? Mi equals 2.0. Vi equals
Now, if you look at the question says how many liters of 0.5 acetic acid solution can be formed from 0.3 liters of 2.0 molar acetic acid solution. So this is your initial solutions. This is your initial solution because it says from 0.30 liters of 2.0 molar. That's why the initial molarity was 2.0.
zero point 0.30. Mf equals 0.50. Vf is to be calculated. Therefore, Vf equals 2.0 times 0.30 divided by 0.50 equals 1.2. Example: calculate the concentration of 1.5 liters HCl that is formed from 0.25 liters of 1 molar HCl.
All right, I want you to solve this. I will pause for some seconds to allow you time to find the solution to it.
Mi equals 1.0 Vi 0.25. Mf is to be calculated. Vf equals 1.5. Therefore, Mf equals 1.0 times 0.25 divided by 1.5 equals 0.17.
An acid-base reaction is often called a neutralization reaction. When just enough base is added to the acid is neutralized. The reaction is called a neutralization reaction. Acids and bases are classified as strong and weak.
All right, this is a new topic under the solution chemistry. This is the background we need to understand before we go to titration. It's unfortunate we are not in the classroom to do the titration, but I will send you the Gizmos virtual titration for you to get the information on. So anytime the school resumes, then you can do the hands-on activities on titration. But meanwhile, these are the background knowledge you need to know. Titration has to do with neutralization. That is, an acid reacts with a base, and then they neutralize each other to give you salt and water. That is the product, salt and water. The two solutions, acid and base, are both aqueous, so there is no precipitate form. You will not get any precipitate during acid-base titration, which is called neutralization. We have three categories which you are going to understand from this topic now. All right, let's go on.
Hence, the nature of neutralization depends upon the strengths of acids and bases. The acid-base reactions are classified into three categories. Category 1, strong acid, strong base. Category 2, weak acid, strong base. Category 3, strong acid, weak base. In all three categories, there are a few common steps that should be applied to perform volumetric analysis. Step 1. List the ions present in a combined solution. For example, in the reaction of HCl and NaOH, the ions present in a combined solution will be H+, Cl-, Na+, OH-. Step 2. Figure out what reactions would occur with these ions and determine the net ionic equation. In the example, there are two possibilities. H+ combines with OH- to form H2O. And Na+ combines with Cl- to form NaCl. The net ionic equation is H+ plus OH- becomes H2O. This is the net ionic equation in general for a reaction between a strong acid and a strong base. Step 3. Perform volumetric calculations using the relationship Mi times Vi equals Mf times Vf. This equation can be written as Ma times Va equals Mb times Vb.
So in other words, we are trying to replace the molarity of initial, volume of initial with molarity of an acid times volume of an acid. And then molarity of final times volume of final will become molarity of base times volume of the base.
For example, calculate the volume in milliliters of 0.100 molar HCl needed to neutralize 50.0 milliliters of 0.250 molar NaOH. Ma equals 0.100 molar. Va is to be calculated. Mb equals 0.250 molar. Vb equals 50.0 milliliters. Va equals 125 milliliters. Hence, 125 milliliters of 0.100 molar HCl are needed to neutralize 50.0 milliliters of 0.250 molar NaOH. Step 1. List the ions present in a combined solution in the reaction of HNO3 and KOH. The ions present in a combined solution will be H plus, NO3 minus, K plus, OH minus. Step 2. Figure out what reactions would occur with these ions and determine the net ionic equation. In the example, there are two possibilities. For this set of ions, the ionic equation is H plus OH minus gives H2O. The ionic equation with these ions is KNO3 soluble in water?
Yes or no? The answer is
hence, KNO3 exists as K plus and NO3 minus ions.
now you see the reason why there is no precipitate, because all of them cancel out. They are all spectators except the water that is being formed. The potassium, nitrate will cancel out. So the only one that is left in the solution is the water.
K plus and NO3 minus ions are called spectator ions. The spectator ions are canceled out. This is the net ionic equation. Step 3. Perform volumetric calculations using the relationship Ma times Va equals Mb times Vb. For example, calculate the volume in milliliters of 0.500 molar HNO3 needed to neutralize 10.0 milliliters of 0.750 molar KOH.
All right, let's see how you do that. Everybody, let's do it. Pause the video and work it out.
Ma equals 0.500 molar. Va is to be calculated. Mb equals Vb equals equals 15.0 milliliters. Hence, it takes 15.0 milliliters of 0.500 molar HNO3 to neutralize 10.0 milliliters of 0.750 molar KOH. A titration is an analytical technique used to determine the volume or concentration of an acid or base. Volumetric analysis is a method involving calculations based on titration. A titration can be performed and the volumetric analysis can be done between Category 1, strong acid, strong base, Category 2, weak acid, strong base, and Category 3, strong acid, weak base. Considering the scope of the topic, only Category 1 is discussed. Example: how many milliliters of 0.250 molar barium hydroxide must be used to neutralize 15.0 milliliters of 0.175 molar HCl? Step 1. List the ions present in the combined solution of HCl and barium hydroxide. The ions present in the combined solution are...
Now, I want you to be very careful when you break down barium hydroxide. Remember these two. The subscript here is going to be with OH because you have two OH in that solution. So you have hydrogen ion plus 2 OH in this form. Barium ion plus chloride ion.
Is BaCl2 soluble in water?
All right, I want you to write this equation. I want to write the balance equation for this hydrochloric acid with barium chloride to produce water plus barium chloride. Write the balance equation, and then you know when you do that, you're going to have two chlorides here because that balance equation will have two molecules of chloride ion in that solution. All right.
Hence, BaCl2 exists as Ba plus 2 aqueous and 2 Cl minus aqueous ions. Ba plus 2, and Cl minus are called spectator ions. The spectator ions are canceled out. This is the net ionic equation. Step 3. Perform volumetric calculations using the relationship Ma times Va equals Mb times Vb. Example. How many milliliters of 0.250 molar barium hydroxide must be added to neutralize 15.0 milliliters of 0.175 molar HCl? Ma equals 0.175 molar. Va equals 15.0 milliliters. Mb equals incorrect. Try again. Mb equals
Yeah, remember that you have 2 moles of OH on barium hydroxide, so that means it's doubled.
.500 molar. Vb is to be calculated. Equals incorrect. Try again. .25 milliliters. Hence, it takes 5.25 milliliters of 0.250 molar barium hydroxide to neutralize 15.0 milliliters of 0.175 molar HCl.
All right, folks, this is where we're going to stop today. I wanted to go back and review this video and the previous one. Tomorrow we have a practice quiz, which is going to cover dilution, molarity, and moles. Yeah. So practice these questions, the last video and this very one, so that the next video, which is going to be your practice quiz, is going to be easier for you. All right. See you tomorrow. Bye-bye.